So when we have our interval, and some of you are having trouble when you're moving from this 2 and 2.5 and moving to an actual range. What does that represent? Well, this represents my time in between t is 2 seconds and t is equal to 2.5 seconds. Step 2 is to actually figure out the height. So, first of all, my height at 2 seconds is going to be equal to negative 4.9 times 2 squared plus 14 times 2 plus 1, which is going to give me a height of 9.4 meters. I'm going to do the same thing at height of 2.5. Height of 2.5 is going to be equal to negative 4.9 times 2.5 squared plus 14 times 2.5 plus 1, which is going to give me a total height of 5.375 meters. Keep those decimal places as accurate as possible. Okay, that means now I have 2 points, 2 and 9.4, and my coordinates 2.5 and 2.5. When time is equal to 2.5, I have 5.375. So my average rate of change. My average rate of change is going to be equal to 5.375 minus 9.4 over 25 minus 2. Now there's a reason I wanted to do this particular question, because when we solve for our average rate of change, we get a negative 8.05 meters per second. 8.05 is a negative value, meters per second. So can someone tell me what this negative speed represents in the context of this problem? What does that negative speed represent? Yes, Julian? A decrease, or okay, a decrease in height, but what does that mean in terms of direction? Jennifer? Well, it's traveling down. Yes, very good. So the ball is traveling in a downward direction. At a speed of 8 meters per second on average between 2 and 2.5 seconds. Okay, very, very straightforward. So now let's go to my next concept. If you guys can write this down. We're going to talk about slopes of tangents and instantaneous rates of change, which tie directly into the derivative function, what you're doing right now in calculus, which is the slope of the tangent line. But what does the slope of the tangent line actually represent? So the secant line connected 2 points on the curve, but a tangent line is a line that touches the curve at one spot but does not cross the curve, at one little spot. If you go to Desmos, which is an app on the internet, and you can actually, they've created a formula so you can trace along any curve, and it'll show you all the teeny tiny little tangent lines. Instantaneous rate of change is the slope of the tangent line. And what that means is that it's an approximate value for the instantaneous rate of change at a point may be determined from either a graph, a table, or an equation. You might need to know this for the final exam. How do you determine the instantaneous rate of change? So copy all of this down. So the next portion is just going to be notes for your own benefit. You're going to find the units very straightforward, not too long, but the test, do not be fooled that that'll make the test super easy. The test is going to revolve around your knowledge, your application of how you can take these values and formulas and draw some meaning from the questions, okay? So, still need to study for the test. Now, you're in very good shape if you finished your 12 tests and you only need 2 tests to complete in May. That's very good shape. If you haven't finished your 12 tests, you need to get to that point as soon as possible. You do not want to be cramming in a test per week. And remember, double units technically should count as 2 separate weeks, so keep that in mind. I won't do that when you're on Unit 12 and you only have 2 tests to go if you want to write it back to back. But if you have 4 or 5 tests, double units count as 2 weeks. Okay, so from a graph, you don't really have to copy this down, you just have to understand it. Of a secant, to calculate the slope of a secant, you need 2 points on the curve that are close together. For method 2, to use 2 points on an approximate tangent line, this is when we pick 2 points both on the sketch tangent line that are extremely close together. There's a difference between secant line and tangent line. Okay, so this is what I want you to copy down. A golf ball lying on the grass is hit so that its initial velocity is 2.5 meters per second. The height in meters of the ball after t seconds can be modeled by the quadratic equation ht is equal to negative 4.9 t squared plus 25t. Copy and complete the table for h for our time as a function of height. Height as a function of time, sorry. So I will come back to this. I just need to check something for myself. Yes. So notice that the average rate of change is now my delta height over delta time. And the intervals, pay very close attention to the intervals. We are going from between 2 and 1 seconds to 1 and 1.5, 1 and 1.1, 1.01, 1.001. We're breaking it down into the teeniest tiny little intervals to see if we can find a common trend and calculate to get as close to the instantaneous rate of change as possible. Okay, so I'm going to concentrate on this interval, what's going on? Between 1 second and 1.001 seconds. That's the interval I'm going to concentrate on. And I'm going to try to figure out the instantaneous rate of change and then compare that. Okay, so I'm going to concentrate on this interval, what's going on? between 1 second and 1.001 seconds.